And I'm live. That is pretty cool. Today is 15th of March 2026, Sunday. And before beginning, a quote from Meditations by Marcus Aurelius. Okay. This one is like very short and just 8 words, 7 words. Okay. This says, be thou erect or be made erect. So my interpretation would be thou erect or be made erect. Like stand up on your own or someone else will make you stand up, I guess, something like that. And we are going to give a contest. Cool. Contest number 1058, because a friend of mine said that this one was pretty cool. Let's see how this one goes. Hello. Shit, already two people are here. Hello. How is everything? Shit. Please explain questions properly. Okay. I'm going to do every single question you have done. I'll just copy paste you. Shit. No, I guess you should do problems that you find. And okay, yep. I will I will explain problems properly. That would be my goal. No, shit. What I did was CP31, like just this. And shit, is your same thing as you? Like, if I do the same thing as you, is your name like modular? I will end up in the same position. No, I do not think I got good in CP because of the questions that I did. It was mostly because of the way that I approach questions and find out what are the things which were essential to solving that problem. And yes, like what were the essential things which were important to solve that problem, and generalize those things and figure out where else could I use these same principles. Yeah, cool. I got an internship in like physics research thing. Shit, I will just copy paste you. Shit, I guess you're going to hack me. Okay, I will keep my eyes open. Yep, the internship. Yes, a physics internship, but okay, yes, I figured. Okay, I will not call you by any other name. Shit, I think it is Krishna who has a lot of names. Okay, I will not call you by any other name. And let's start the contest and do this CP31 sheet. This is like better. The internship. The internship was about writing a research paper on Prince Rupert's drop, and I did do some research on how glass is made and what are the different types of glass, tempered glass, non-tempered glass, and difference of materials, or what is heat shock and stuff. But I was not liking it. Hello. Why don't you apply any MNCs? I guess right now I'm just afraid. I don't think I'm good enough, but I have summon up the courage and just do it. Yesterday there was big code event. Uh, the big code. And yep. After this chess website is done, I will start applying on MNCs and stuff. I just have to like man up. Yes, I should. You are right. I should. I'm just being like weak. The big code 2026. And yesterday I gave this thing and I don't know. I performed bad. Questions were difficult and I had no idea what to do. Okay. Yep. Yes, I will. You are like exactly correct. As your name suggests. Okay, let's give this one. A friend of mine said that his friend solved B after like 2 hours and his rank was 2000, which is crazy. So let's see. My goal would be to solve 3 problems at least in 1.5 hours, and we'll see how it goes. Thou shall erect or thou shall be erect. That is what Marcus Aurelius said. Okay, don't forget to give me yes, of course, like of course, if I can help anyone, I would of course help. We are connected on LinkedIn. Shit, sorry, I don't know you by your other name. I only know you by Krishna. Okay, let's give the contest. Okay, shit. Shit. I will look it up. I will like remember. I will say hello to you, Lokesh. Why? Start virtual contest. Let's start the virtual contest now. 35 at 37. Cool. And we will see how it goes. 1, 2, 3, 3. Cool. It is going to take 1 minute and this much time. Okay. Do we need to do something? Let me check, is the tree sitter working? Tree sitter should be working, and it is working. Cool. We are getting these cool highlighting, and you can check if the tree sitter is working or not by inspect tree. And look at this. This is your whole abstract syntax tree built by the tree sitter. This is cool. Cool. And I would like to turn off Codium. Codium is disabled. Cool. Okay, cool. Cool. 35 seconds. Let's go. We have to do at least 3 problems. That would be the ideal. And I guess today is also a contest, a division 2 educational round contest. We will see how that goes. But before that, we will give this one 1085 division 1 or 2, 1 plus 2. And this one is 3 hours long, but I don't think we will stay here for 3 hours. Okay, okay, Mario. Let n be a positive integer. Mario has a binary string s of length n. In one move, he can choose any position between second and the second last, such that it is between ones, such that it is between two ones, that is okay, and then si to be either 0 or 1. Okay, Mario can perform this operation and then set si. Okay, change it. Mario can perform this operation as many times as he wants, possibly 0. What is the minimum and maximum number of ones that can be in the resulting string? What is the minimum and maximum number of ones that can be in the final string? Maximum is this. We cannot change these things at the corner. Yep, we cannot. And if we have at least like 2 ones, which we can make this one 1. Yep, there is no chaining in this. There is no chaining in this. Yep, I cannot change this. Cannot change this. I can change this. And shit, yes, if we can change this, then we can also change this. Okay, I think this can be counted as one sequence in which we can change everything in the middle, I think, except the ones at the last. I think we can change everything in the middle here. We can first change this to anything. We can then change this after changing this. And we can change this after changing this. Cool. Yep. So we have to come from the ends to the middle, right? So we do have the ability to make everything in a sequence of ones where the maximum number of continuous zeros we have is only 1. In that sequence, we can change everything to a 1. So that would be the maximum number of ones. And maximum number of ones is, wait. How do we output? Output the minimum and maximum number of ones. So in this, the maximum number of ones would be, we have this one, and then we have this sequence where we have 1, 2, 3, 1, 2, 3 ones. So 6 plus 1, answer is 7. Cool. So in a sequence like this, we can change everything to 1. That is cool. So maximum number of ones is easy to calculate, but the minimum number of ones, how do we find that? They are saying it is 5, so which means we cannot change this, we cannot change this. Right, let's say we do have a sequence like this. We have changed everything to a 1. Okay, and there could be two conditions: even number of ones and odd number of ones. This is odd number of ones. Here we can switch this to a 0, and then we can switch this to a 0. So there were 5 by 2, that is 2. We reduced 2 ones, and if it were even, if there were like 4 or 6, then we would change this to a 0. We would change this to a 0, but not anything else. Cool. So the number of, if the size of our segment is, let's say, n, then the number of ones that we can keep, the maximum number of ones we can get is n, and the minimum that we can get from a segment like this is, from 5 we can get 3. So like n plus 1 divided by 2, and in this case it is 6, and we can get 4, and I do not think we can get any less ones. Yep, we cannot get any less amount of ones than this. Or yep, I do not think we can get any less amount of ones than this. 6, how do we get to, if the number is even, if the number is odd, we do plus 1 divided by 2, but if the number is even, we do by 2 plus 1, we get 4. Or we do not do this, we just do n by 2 plus 1 in both the cases. 5 by 2 is 2 plus 1, we get 3, and here 6 by 2, 3 plus 1, we get 4. Cool, I guess we can do this now. Cool. Hello. And I hope, yep, everything seems cool. Yeah. Boilerplate. N, begin N, and shit, how do we have the input? We have it as a string. And okay, int mn equals 0 and mx equals 0. Let's say, okay, and for int l equals 0, r equals 0, l is smaller than n, l equals r at the end, and for int I, or not for, but while I are smaller than this, and int z equals 0, right, we will just bool in equals false. Right, so in r has to be smaller than n, and either if in we are inside a sequence and we are inside a sequence, and let me also give it here. Yep, here when we are inside a sequence, right, inside the sequence, if this is r equals 1, or or SR equals 0, and with this equals 0, but Z also equals 0. Then we can move, I think. Yep. And here if SR equals 0, Z plus plus. Okay, R has to be smaller than N within the range, and here if we are N equals we only have to check in when we are checking for this whole thing. Yep. Or SR equals 1. R has to be within range, or then we are already in a sequence and the number of zeros is equal to 0. If we are inside a range, shit, what if the last number was a 0? We would not like to have that. Yep, we would not like to have that. We can check for it, but yep, we only go inside a range when the first number is a 1, right? And then when we get out, we'll say 0 equals 0 and N equals pause, and if yep, and ln equals r minus l if sr might be like outside the range at this point. Yep. If r is smaller than n, if wait, we want to look at the second last. If sr minus r minus 1 equals 0, then ln minus 1. Okay, and then mx plus equals this whole ln range, and mn plus equals ln by 2 plus 1. And I guess we are okay. At the end we can output mx and mn, but like it's the order is wrong. First comes mn and then mx. Let's see. Shit, out of bounds. Shit, yes. R minus 1 is still out of bounds. When are we indexing? We are indexing here and we are indexing here. If r is smaller than n, only then index. Shade also, yep, makes sense. Here we have to do an else where we do z equals 0. Why out of bounds? Out end time, and we see cool We saw 3, and then why did we see? Yeah, new line makes sense. 2 3 is the right answer for the first one. And then 0, we saw this thing at 0 for problem number this. Cool. Shit, makes sense. We are indexing in there. Cool. Okay, makes total sense. Yep. Okay, we should not be indexing here. Do this later on, and if n, and yep, if we were inside something, only then do r minus minus. What do we see now? Okay, shit, it is still running and time limit error. Why? Okay, we are never getting out of this while, it seems like. We are increasing. Shit. Otherwise, we are never increasing r. Makes so much sense. R always ends up at 0 at a thing which would never be a part. Yep. So we can do r plus plus. R plus plus is like totally okay. This is wrong. 4 and 5. Why is this thing wrong? Let's see. See out ln. In this we said 4 and 5. Okay, first range was 0 and then the second one was 5. 5, cool. So maximum number of ones is going to be 5 and the minimum number of ones, shade, in this case it is going to be, wait, no, it is not going to be 0. The minimum number of ones in the second case can be 3. We can turn this thing off and this thing off. In yep, so why are we saying 4? 4 does not make sense. Shit, because of this we are doing ln was equal to 0 in the first case. Yep. So only do this if we are in something. Yeah, if it's a bit of a hacky way, but okay, if sr minus 1 equals 0, I guess now, shit, okay, now I was expecting it, nope, put these outside, and if this was the case, then ln minus minus. Cool. But will this fail? I guess not. What we are doing is we are splitting this whole string into ranges, and one range consists of ones, just continuous strings of ones, but it will occasionally have zeros, and only those zeros which do not occur more than once in a continuous location. Like this thing can be considered a single block, and these two zeros can be included because these two are only appearing once in continuous place, because you can change them into ones. So that is cool. Let's see. Shit. This should be okay. It That has been 18 minutes. It has taken 18 minutes to do the first problem, which is quite a long time to spend, and this might also fail. Okay, shit, this works. Okay, cool, that is very cool. This works, cool. And what is the rank now? Just to be greedy. Shit, 4,000. Very bad. 4,000 is very bad. Okay, let n, m, l be positive integers. Okay, three integers, n, m, l are positive. You have made the unfortunate decision to work as a night guard at Freddy Fazbear's Pizzeria, where there are M animatronics numbered 1 to M waiting to jump scare you. The night consists of L seconds numbered 1 to L. The jth or the mth is or the mth animatronics has a danger level DJ. Okay, we have another array dj, and initially d1 till dm equals 0. Okay, danger level of all the animatronics is 0 initially. Every second the danger level of exactly one animatronics will increase by 1, and throughout the night you are able to observe all the values of dj at the current time. For example, if m equals to 1, possible list of danger levels after 5 seconds is this. M equals this. Wait, why m? When okay, if the number of yeah, cool, 2. You are not defenseless, however, at each of the n fixed times ai, where 1 to l is the number of seconds at each time en smaller than equal to n, l, all the values, and the next value is always greater. You can shine your flashlight on exactly one of the animatronics ji of your choice. Okay, there are a lot of moving things in this. This occurs immediately after the ai second and sets its danger levels back to 0. That is, a dj becomes equal to 0 of that animatronics that we chose, j. Note that this choice is made independent for independently for each flashlight. Use ai. Flashlight use ai. Ai is a flashlight. Okay, continuing the example from before, if ai a1 equals 5, you can choose to flash the second animatronics. At that time, the danger levels after 5 seconds will be this. Get the overall danger. Let the overall danger be the maximum danger across all animatronics. That is maximum of all the things, all the DJs. Okay, you will lose if the overall danger at the end of the night after L seconds is greater than X. Find the minimum value of X such that regardless of the actions of the animatronics, you can guarantee the overall danger will be less than or equal to X. Okay, a lot of moving parts are here. The first line of the test case contains N. What is N? M is the number of animatronics, L is the number of seconds, the number of flashlight actions. Okay, N is the number of flashlight actions, animatronics, and the length of the night, respectively. The next line contains N integers, these things, the times at which you get to shine your flashlights. Okay. We have just one flashlight which we can shine at the 10th second. Okay, this seems more simpler now. The night, there are just two animatronics, and we can flash a flashlight at 10, right? I guess 5. Yep, 5. We have 5 flashlights which we can shine at these things after this second. Okay, and the night is 32 seconds long. Here, 1, right? The best strategy okay The thing is, after the last time, after this time, the bot, the minimum number of answer, the minimum number of x is going to be at least this, the length and the last time that we can flash a flashlight. And also, is ever n equal to, n is never equal to 0. Okay, so we have a minimum limit for our answer, which is 32 minus 25 in all the cases. This number minus this number, this number is the total duration of the night, and this number is the last second where we can flash our flashlight, and after that we do not have any control of flashing anything. So the person in charge can always choose a single animatronics robot to like give it all of the remaining danger, so at least they would be getting that much danger. And before that, I guess their best strategy would be to spread their expenditure in all the possible places. And I guess we can just simulate that because the upper limit is 10 power 5. Can we simulate the whole thing? And our stop points would be these points. Okay, let's do a little bit of simulation for this one. Here we have the night is 32 seconds long. So okay, cool. Let's do a simulation in our heads. And there is only one animatronics. Shit, there is only one animatronics. So the answer in this would be, I guess, 7. Yeah, cool, 7. Here the number of animatronics is 3. Okay, let's do some Excalibur. Cool. And this is the problem right now. Here there are 3 animatronics, right? One, two, three, and the first time that we are spreading a flashlight is here, is at 13. So we have a value v, which means the first time at second 0 we had no danger, and at second 13 we have 13 dangers which we can distribute. And the best way to distribute would be 4 4 5. Why? Because that is the most equal amount of distribution we can do. 13 divided by 3 is 4, and plus 1 remainder, give it to some anything. And yep, then we would obviously choose this one and decrease its danger to 0. Then the next flashlight comes at time 37, which has a difference of 24. We had 24 things to distribute, and I do not think that making use of this animatronics to like increase the danger of this one helps us. It would be cool to increase the danger of these two, and we can spread this danger 24 equally between these two and increase their danger by 12 each. And here we will have 16 and 16. Then we can flash a flashlight at 37 seconds, and let's say make this one equal to 0. So this animatronics has a danger level of 16 and 3 more seconds, so increases by 3, and 19 is the maximum thing that it can get. Third answer is 19. Cool. But we were to do this, we were able to do this as a human. How do we tell a machine to do this same thing? I guess the number of animatronics helps. Yep, shade. The number of flashlights and the number of animatronics is very helpful. Here, yep, shit. Shit, yes. Let's say n is the number of flashlights that we have, and The number of animatronics is m, which is like given in the question, and m. If n is greater than m, if n is greater than m, if n is greater than m, then we would be able to at least once make everything equal to 0. If n equals m, like in this case we had 2 flashlights, but if we had 3 flashlights, what would be the case? Let's say we had one more flashlight at second 5. What would be the case then? 5, 13, and 27, and we had 3 animatronics. So for 5 we would spread, make them 1, 2, 2. This would be the danger level, and we will make, let's say, this equal to 0 at the second 5. Then we had 8 more seconds, 8 animatronics to spread, and it would not be a wise decision to not include this one. Not include this one because there are 2 more flashlights, this one and this one. At one chance we will make this one equal to 0, and the other we would make this one equal to 0. So this thing, this 8 danger should be spread equally between these, all of them. And how? This is 0, this is 1, this is 0, and this is 2. How do we spread them in? And our goal is not to spread this 8 equally. Our goal is to spread them such that the difference between the danger levels of each of these animatronics is as low as possible. That would be the goal. So right now, yep, the difference between this and this is 2 seconds, and 2 danger levels, and this is 1. You would like to change that, and let's bring all of them equal to 2 first, which you can do by adding 1 more to this and plus 2 this, and here we have, out of 8 we have 5 remaining. Now these are, all 3 of them have a danger level of 2, and now we can equally spread this 5 by plus 1 plus 2 plus 2. This is as equal as it can get. So 3, 4, and 4 are the danger levels. Now right, okay, let's like solve this in steps. If the number of flashlights that we have is smaller than the number of animatronics, if that is the case, then, and we do not have to look at the time, we can first of all change the information that we have. We have 3 things: n, which is the number of flashlights that we have, or the number of times that we can use a flashlight; m, the number of animatronics or machines, you could say; and then the third number is l, the number of seconds in the night. And then we have an array whose size is n. Cool. So we can first of all change this array from a timestamp array to a difference array, which would look like here. If we have all these elements, the new array would look like, we can add like 0 at the start, and the new array would be the difference of this and this would come and become the first element, the difference of this and this would become the second element, difference of this and this, and so on. Cool. The length of this array would also be n, because like we added a new element and that made the length of this one to n plus 1, and this new array n, this new array uh, has one element for each adjacent pair, and there are n adjacent pairs in our array of length n plus 1. Okay, cool. Right. So this is how we are going to represent our information, and there are three cases. N is smaller than m, n equals m, and n greater than m. Let's solve this one first. We don't have to hurry, because yes, we don't have to worry. We have to like be very careful with what we are doing. If n is smaller than m, if n is smaller than m, how much smaller? If n is 2, if n is 2, m is 4. N is 2, m is 4. So max, at max, this thing can destroy 2 animatronics. Cool, shit. I guess then in that case, we can just find out the answer. We would not mm, use all 4 of these. We would, in this case, when n is smaller than m, in this case, we would use n plus 1 animatronics, and our answer is easy to calculate. In this case, when we are using n plus 1 animatronics, we know that since there are just n flashlight instances, this thing would be able to destroy out of these n plus 1 n animatronics, and at the end we would have one left, which is cool. So what we do is, since we have this array of differences, we would say d1 would be divided between n plus 1 things. We would have a current counter which would be initially equal to 0, and we will keep increasing it, and we will have a loop which goes through all these elements from d1 to dn, and on each element we will do c plus equals d I, whatever the current d is, divided by n plus 1 minus I minus 1. Why n plus 1 is the original number of elements, and I minus 1. No, just minus I. Minus I means how many elements we have removed, how many or animatronics we have removed. And I guess this would work in the case when n is smaller than m. And I guess we have solved this. At least this case is solved now. Cool. N is smaller than m is solved. 1. Done. And when n equals m, in this case we know that the person can destroy n plus 1 animatronics, which means he, she, it can go through all of the animatronics and destroy them once. All of them. Destroy them once. Destroy them once. Let's have an example. Let's say n equals 5, which is also equals to m, and let's say L equals 10, the length of night equals 10. So we have like 5 numbers. Right, and 2, 4, 6, 8, and 10. These are the times that we can do a flash. So our best chance would be to split all of these as much as we can split. So this 2 we would like to split between 2, right? And then we do a flashlight, we make this 0, then we get a difference of 2 again, or instead of this we should keep an array of differences. So we would have like 5 times 2, then this 2 would be also like to be spreaded. Spread it wean these elements, the zero ones, and then let's say we make this one 0, then the next two would also like to be spreaded like this we make this one 2, let's say, and then this next two would also like to be spreaded between this and this, right? And we make this one equal to 0, and then the last two would also like to be spreaded, and we would not spread it here, we would spread it here and here, and we would get 2 as the final answer, the maximum value. Okay, before the last one, before except this last d value, whatever it is, our strategy for the rest would be to spread, to make, to try to make all the values which are there as equal as possible. To increase the value of the lowest one, to increase the value of the lowest one. Yep, to increase the value of the lowest one. Because we know that the highest value is the one which will become 0, which will be made equal to 0 by the other player. Wait, I think we can take a simpler approach if we, let's say we have, not just let's say, we do actually have all these animatronics, right? And the problem is solved for n is smaller than m. When n, this value is smaller than this, then we have already solved. We know what to do. Yep. We do know what to do, but when these two are equal to each other, in this case the answer is 0, I guess. Yep, answer is 0. Smaller is equal to, and here the value is like greater, and the answer is 7. Let's write a solution for at least this much. CPP, smaller plate, N, M, and L, N, M, and L. Vector A, size N, 0 for a reference X and A. C and X, take in all the X, and if rs equals 0, yep, cool. Or we could say rs 0 is okay. If n is smaller than m, if n is smaller than m, in this case we will do a like simulation of sorts, or wait n plus 1 and I equals 1 I smaller than n, I plus plus, not just smaller than, equal to n I plus plus, everything is equal to 0. In a we will do ai, take into ai, and our vector diff of size n, initially everything equals 0, would be for int I equals 0, I smaller than n, I plus plus, and diff I equals ai plus 1 minus ai. Cool. And here for int I equals 0, I smaller than n, I plus plus. In case, yep, here difference we will have, yep, we already have res plus equals the current value, which is diff I divided by n plus 1 minus I. I guess we are okay. At least for like some of the key. It is a bit messed up. Mhm. N, M, and L. We should be getting the right answer for number 1, or not number 2. For number 3, we should be getting the right answer, which is 19, but we are not getting the right answer. We are getting 16, which is messed up. For the third one, we are getting 16. 13, yep, and 27 should be there. 13 and 20. Shit. 13 and 27 should be there. Let's say the out. Shit, I think there is a print function. We can just use the print function and give it if. Shit, no. Shit. There is a default function. std function c++ to print vector. std print. We can just give standard print. For each override. I guess I messed up. The out diff. Diff is correct. Diff is correct. This is the correct diff. This is the correct diff. Shit, makes sense. After this, rs plus equals the minimum value, rs plus equals l minus a dot back. Cool. Correct answer for this. And why do we have a 0? 0 is the correct answer in this case, at least. Cool. We should be getting the right answer for the second last case, but we don't get the right answer. Second last case, we do not. (1987). Second last case, we should be getting the right answer. Seven. There are 7. Makes sense. What if we are not able to spread them? Shit. Kakashi, if you are here, you are right. Shit. And this is just problem number 2 in this contest. Okay. This is about spreading. 1474, but the actual answer is 3 greater than the one that we printed. Here, 3 more than this one. Where are we losing 3? Three is being lost somewhere. 3 is being lost somewhere. 6, 1. Every value is greater than 7. Okay, yes, I think there is a distinction to be made. If uh, diff I is smaller than diff I is smaller than n plus 1 minus I. N plus 1 minus I is the number of things into which we are trying to distribute this current value. Only then. But our answer is smaller than what should be there. Our answer is 1474, but actually 77. 3 less. 3 less than this. Shit. Okay, 3 less, 3 less, 3 less, 3 less, 3 less. If n is smaller than m. Shit. Okay, if n is smaller than m, we are refreshing stuff. If we have 3 boxes and we will keep, there are 10 things that we can distribute in these 3 boxes in like synchronous manner, and we are going to distribute these 10 things into these boxes in, let's say, 3 different. There is always going to be the last one. There is always going to be the last one. In n smaller, as n is smaller, minus a dot back, l minus a dot, l minus a dot back. Let's say we can distribute these 3 things into these 3 boxes in 3 different bursts, and okay, we in this initial 3 we distribute it equally, and after each distribution one of these boxes will become 0, and we will assume, not assume, we know that the box which has the highest number of things will become 0. Okay, when we do our first distribution, the maximum difference between the value of any box is going to be 1, because every box started with the value of 0, and no matter which number we have which we are going to distribute, we will distribute all that equally between all the boxes, and then we will have a leftover which we will spread out evenly, like yep. And the maximum difference between any two boxes is going to be 1, because we are not going to give all of the leftovers to a single box. We will distribute the leftover also, the remainder. By that is what I mean by leftover. Okay, and cool, cool. So we have two values, like let's say x and x plus 1, and then one of these boxes which got a remainder becomes 0. Now we have three values: 0, x, x plus 1. The next value which becomes 0 is also going to be x plus 1, and so on. All, I think we can say as a fact that, right, okay, we will have these three values. Now with the next distribution value, whatever it is, our main objective would be to reduce the difference as much as possible. The difference between these two is just 1, which is cool, acceptable, but the difference between these two is x. So we would, let's say, the next difference, the next distribution di, we will use it to fill up this 0 value thing and make it as big as x. Now there can be multiple cases. If what if this di is smaller than x? In case di is smaller than x, and we will not think about the future, we are just thinking about what happens right now. Yep, what happens right now? What happens right now? If di is smaller, then we have x, x plus 1, and di now, and then do we keep a multi-array, multi-set to represent these? If we do keep a multi-set, what would be the time complexity? Time complexity, shit, 1 second. We just have 1 second to do all of this. Multi-set, we will go through all of these d values, and there are going to be n, which is 10 power 5 of these d values, and the maximum time each operation can take is going to be log n, not greater than log n. Log n is the maximum time we can get. Can we use a binary search here? Because we do know that the minimum value we can get is 0 if we, no, the minimum value we can get is not 0, but it is the total time, which is L, minus the last time that we can make, like this, minus an, the last time that we can do a flash. This is our minimum value that we are guaranteed to get, and the maximum, let's say maximum, which we do know is wrong, which we can never get, would be L plus 1. We can never get L plus 1 danger values on one animatronic, because there is no L plus 1, because there is not enough time. There is just L time, and L seconds, and in 1 second we can increase the value of one thing, so we can never have a danger value of L plus 1. Cool. So our range of answer is on this minimum value mn and L plus 1, where L plus 1 is not included, mn is included. Can we do binary search? Say m is a value in this range. Can we test? And we do also know that if we were to plot this from mn at some point and then L plus 1, and here we have false and true, these are true till some point and then they become false. So we want to find the highest value which is true. Can we, given some random value m within this range mn and L plus 1, can we find out what its value is? Is it not possible, false, or is it possible to get it true? And that is binary search for answer. Okay, can we check if a value is reachable or not? If a value is reachable or not. Let's see. In this one, the answer is 19. So let's see, can we get a value of 15? We should be able to get a value of 15 here. So let's say 0 to 61, let's say. And it was possible to get all these values till 19. And then after 19, nope. Till 61, nope. After, yeah. So 15 somewhere here gives true, and everything after 19 gives false. So how do we find out that 15 is like okay value to have? Let's make the difference array. Difference array would be 3, then 3 minus 17 would be 14, then 3, then 8, then 8, then 8, then 1, then 5. Yeah, cool. 5. So first of all, we will see that the minimum value, which is 60 minus 50, is reachable, because after 50 there is no flashlight being used to reduce the value of any box to 0. So we can put all of these 10 credits at some point, and cool. So after that, out of 15 it is easy to get to 10. We need to figure out how to get these 5 danger level values. How to get these 5 danger level values? This is the distribution. 5. It would depend on n, that is how much flashlight we have. We need to squeeze out of this 5 points. Squeeze out of this thing 5 points. M, we know M is 5. That is, there are 5 buckets, we could say, into which we have to distribute these values. Let's say this 3, we distribute this, like this is like lower than M. So this does not help. Wait, this is lower than M. 3 is lower than 5, the number of buckets. So I think maybe this cannot help us in any way in the final answer. Not just M. How many flashlights do we have remaining after this? Would also be a factor. Yep, would also be a factor. Shit, yes. This is our flashlight number one. After this, we have like seven flashlights. Seven flashlights. Okay. Shit. The number of remaining flashlights, let's say R number of remaining flashlights, the current DI value, which is 3, and the number of buckets, which is like M. So if DI, if R is greater than M, I think nothing can help us. Whatever this DI is, we do have a possibility in which we are going through all of these M buckets. So I guess while remaining number of flashlights is greater than M, we cannot do anything. So in this case, this 3 can be discarded. Only these last remaining 5 can help us do something. I think. I think we can just discard these first 3 and only look at these distributions. These distributions. Okay. Okay. And can we even disregard this 8? I think. Okay, let's say 8, 8, 8, 8, 8, 8, 1, 5. Okay, and we have M buckets, 5 buckets. This 8 can be distributed into 5, and we will assume that the starting value is 0. We will assume that the starting value is 0. Okay, starting value is 0. We distribute this thing into all of them. 1, 1, 2, 2, 2. That is 8. That is 8. This becomes 0. Now we have another 8. This thing became 0. I guess before this we have to be able to solve the case when n is smaller than m, which we have not been able to solve. Okay, here this thing does not work. When n is smaller than m. We should be getting the right answer here, but we do not get the right answer here. Yeah, rest, a comma. 2, 6, 4 is actually crazy, because this should come here. Yep, it was 0, 0, 11, 13. Let's look at here. In the third, it can be proven that the minimum possible. Okay, thank you for this much information. In the first test case, there are 2 animatronics and 10 can be spread between them, and you get to flash. You get to flash. The wording is like very, could be easily misinterpreted. You get to flash after 10 seconds. We will show that 5 x equals 5 is always possible after 10 seconds. Notice that one animatronics must have at least 5 danger and the other must have at most 5 danger, so we can flash the higher one and get a final danger level at most 5. It can be shown that 5 in the minimum possible is the minimum possible value of x. 5 is the minimum possible value of x. Yes, that is. Ooh. Okay, I guess if we go through this example, that would help us. Okay, here we have like 7 buckets. We have 6 which we can distribute among these and make it 1 1 1 1 1 1. Then we have the 7, but before we get to the 7, we can choose one and make it equal to 0. Now we do have a 7. We distribute it, but how do we distribute it? We just distribute it equally 1 2 2 2 2 2 1. Cool. And now we choose one thing and make it equal to 0. We choose this and we make it equal to 0. Now we have 77. We have 66 which we want to distribute. I guess this is where the problem came from. The overlapping of remainder. Overlapping of remainder. Yes, remainder overlapping. Here in remainder, yes, we didn't take into account the remainder. Our answer at this point is like 2. If we were to stop right here, our answer would be 2. But in this, we got 0 and 0. So that is the shortcoming. We are not taking into account remainder. Remainder is also there. And it. So yep, but we should not always take and like add 1 because of the remainder. If I guess if yes, there has to be a if. Here when we did the first splash is flash, we had 1 1 1 1 1 1 and 0. We distributed the 6 into 6 things and 1 was 0. Here we can say the remainder is 6. We have 6 boxes in which we can have an extra 1, right? And after this we do know that the remaining number of flashes after this, the remaining number of flash, let's say we do a flash, right now we do a flash and we still have these things remaining ones. I guess if the remaining number of not the remaining number of flashes, if the remainder is more than 1, then we can keep it. I think if remainder is more than 1, well, whose remainder? If I remainder with n plus 1 minus I, if this thing is greater than 1, then this plus plus. This might just backfire, I don't know. There's like hit and try. Okay, it worked. Okay, shit, it worked. That was the thing. At least in this case, when n is smaller than m. But is it okay? Is it okay to do this? Is it okay? I think it is okay to do this. Yep, it is okay to do this. At least here, I think it is okay to do this. Okay, I think it is okay to do this when n is smaller than m. But when n equals m, let's say this was 7 instead of this, and we had, after this, let's say 7 more. Well, let's work with a like simpler example. N equals 3 and M also equals 3. There going to be 3 flashes. M3 means there are 3 boxes. Initially all of them 0, and let's say the night is 15 seconds long. L equals 15, and the distribution, let's say, is equal 5, 10, 5, 5 and 5. There are 5 distributions. First flash is at the 5th second, second is at the 10th second, and the third is at the last second, 15th second. These are the distributions. Okay, then this thing, we spread this equally and we get 1, 2, 2. Cool, no problem with this. Right here, the remainder, if we were to go with our logic, the remainder is greater than 1 because there are more than 1 boxes which have a higher value than the lowest value. So let's keep a track of this, right? And then we make this box equal to 0. Now we have 5 to distribute. And let's just say this was our whole problem. Shit, if this was our whole problem, if we did have M equals, shit, no. Shit, okay. Uh, yep. Going into the next distribution of this new next 5, we have 1 here, which we would have gotten because 5 by 3 is equal to 1. We do have a 1, but we also have 1 extra here. And then we distribute this thing. And we distributed like we just give 2 here, and now we have 3 things remaining which we give equally to each, and we have 2, 3 and 3. Then we make one of these 3's equal to 0. Now we have 2, 0 and 3, right? And again the remainder is more than 1. We keep track of that. Then we plus 1 again for this one in advance. And now we want to distribute this 5. We would make this thing equal to 3. Let's say we have 2, 3, 3 and 2 more things to spread, and we would like to spread them in between these two. Or shit, we can just like skip this one. We can just totally ignore that one of them was equal to 0, and let's say we have 2 and 3. These two are the only ones, and we can just increase their value. We have 5 to distribute. We will give 2 to this and 3 to this and make both of them equal to 5, and our final answer would be 5. We have a 5 remaining. This is the case when n equals m. I think when n equals m, the method that we are using when n is smaller than equal to m, I think we can use a similar method for n equals m. Let's say we have 3 things and we are going to make ones, each of them equal to 0. Each of them will become 0 at some point in their journey. Hello, shit. Bro, I'm back. Really? 67? Wait, what? 67 and big 27. I think from a profile share. Okay, cool. 3 of them were done today. Cool. Which problem is this? It is this one. B. I'm thinking of posting solutions of each of them on Twitter to solidify my understanding. Okay, that is cool. Something you can do. Yep. B. Hello, Eric. This and this are just shit. Okay, you are stalking now. Damn, 2000 rating is good. Wait, 2000. Who's this problem is 2000 rated? Shit. Or like you are commenting on my future plans. Shit, you are a businessman. You do look into the future. Okay, here, cool. We have n equals m equals 3. We do know that one by one we are going to make each of like whatever the contents are of these boxes equal to 0. And we have d1, d2, d3, d4 numbers which we are going to distribute among these three. Distribute the first one equally. Cool. This plus equals d1 divided by m. Right. I think this much we can always get this much. Maybe we can always get this much. Um, okay, let's just think about the case when n is equal to m. I was thinking also trying to include the case when n is greater than m. That I don't know. When n is equal to m, we'll distribute this. Yep. I guess in this case, we will get this much, and then a remainder. We will also get remainder if remainder is greater than 1. Let me send again the problem. Take a break. Wait. Cool. No, he's saying yep. But also he's still in college. Who? Me? Yes, me college. Oh, shit. Yeah. No. I have to start his private sheet soon. Okay, let's go. Like do your best. You have done 470 problems. I cannot get to your. You do not have to get like. I spent 4 months solving these problems. So 4 or 5 months. Why do you expect yourself to do the same thing in 1 month? Maybe you can. You are genius. I don't know. But yeah, cool. During the education round tomorrow. No, no, no. 3 done so far, 8 more to go, 11 a day. Okay, like keep in mind consistency, like keep your schedule. Do not make be too hard on yourself so that you give up, right? Yep, keep that in mind. And nope, I won't be giving the educational round tomorrow. Sequel. We can distribute this. 0 to L is our timeline. It just feels like I can do this in some time. Just give it more thought and it will work out. When n equals m equals sh- uh, 0 here 3. In this case we put this value d1 by m. Okay, let's say we put some value in some x value in all of these. One of them becomes 0. Now we do know that the remaining number of flashes is 2, which means this x will go away and this x will also go away. So it makes sense to put some thing here also. Let's say we distribute y in the next turn equally. Shit. Okay, shit. Okay, now I think we can think about this. Now the remaining number of flashes is 2. After doing one flash, the remaining number of flashes is 2, and the remaining number of boxes is 3, which is the same as n smaller than m. And I think we can just think about this in terms of as if we had a base to work with. Instead of all the boxes being 0, we have some value in some of the boxes, and we just solve it like a normal n is smaller than m case, which we do have a solution for. When n is smaller than m, we do have the right way to solve it. Shit. So okay, this can be stated as we do have a solution for n smaller than m. So all the conditions where we have n is smaller than greater than equal to m, we can convert these into this condition and solve them there, take it from there. I guess that is cool. Current rating is like, I guess 1350 something. I have already spent more than 1 hour on this. Cool. 1357. Cool. I want to reach 2000, and that will take some time, but yeah, I will get there. Hmm. I think we can do this. We can do this. Of course, we can do this. And if greater than equal to m, we can convert it into this situation. N is smaller than m. Okay. We just have to think more in this. Okay. When n equals m, n equals m. Let's say we have 3 boxes in the first go. We okay, and we are not even thinking about remainders right now. We are just thinking about the base value, which we do know for sure. We can equally distribute in all the boxes. We make all the boxes have a value of x. Then we make one of them, we flash one of them and we make it equal to 0. So 2 boxes. Now n equals to the remaining number of flashes and m equals 3. We have 3 boxes and there are going to be 2 flashes, right? This is a cool thing. So we do know when n is smaller than m, it is good to distribute our stuff in n plus 1 boxes, because n boxes would be made 0. So we will have 1 box remaining. So in the next turn, if let's say we have y or like d2 material to distribute, we'll distribute that into 3 boxes, which is 2 plus 1 3, n plus 1 3. So we'll do d2 divided by 3, whatever, let's say it is y. We will do plus y plus y plus y. Cool. And in the next turn, this will become equal to 0. Okay, this will become equal to 0 and n will become equal to 1. Now, let's say we have our final value d3. We want to distribute the d3, which we will distribute into two boxes. Two boxes, and cool. So d3 by 2, let's say it is equal to z. So we will not distribute it into like this 0 box. That does not make sense. Z and z. Cool. And we choose this one and we make it equal to 0. Now in this case the answer is x y plus z. We didn't get this x. We never get this x. I guess this is an indication. It says that if we have n greater than m, we should only consider the we will have a like array d of these distribution values which we are going to distribute at different intervals. Its size is n, the size of this thing is n, and if n is greater than equal to m, we will only consider the last m values or last m minus 1 values. M minus 1 values, the last m minus 1 values, because in this case also we this x got obliterated. We didn't get this x. This got like deleted, removed. I guess we just look at the last. Let's try the hypothesis, for which we just try the hypothesis. I. We have to decide what I to start at. I equals 0, and if n greater than equal to m, in that case I would become equal to, from the last element, the size of diff is n, and n minus 1 is the index of the last thing, and the last n minus 1, I guess we just do minus m. We want n minus the index n minus I to be equal to m. That is what we want. So I equals n minus m. Cool. Okay, see, this might, yeah, probably does not work. Cool. Okay, we are failing in this case also now somehow. Why are we getting wrong answer for this? We were getting right. No, shit, we were not getting the right answer for this one. But okay, like this is, I guess, better than something else. We can explore the fourth one here. Fourth test case. This one. This one. 2, 2, 7. When n equals m. Yes. see out a little bit of space. Cool. 0. This thing begins at 0. Makes sense. We are only considering the last m items. We should consider the last m minus 1 items, I guess. Plus 1. Okay, it is even lower. Wait, no. Before we begin, I would like to go to the washroom and I will be like right back in 1 minute. Where is cool? Include love is cool. Shit, why do you keep switching your accounts? You have been here like sworddish shit. Are you trying to increase my subscribers? Shit, by making multiple accounts. Okay, here for this one. And look at this. This switching between things is like pretty cool. Look at this thing here at the top. This is called aerospace. We can use this for in Mac for like tiling, window management and stuff. It's pretty cool. Here, this one. Cool. We have this. Okay, this is that we have two boxes. Okay, we have two boxes. If we think about this in terms of differences, we have 1 and then 6 and then 1. The 6 we will distribute in these equally like this, like so. Yep, one of them becomes 0. Then we have a 1. Where do we give it? Give it here. This becomes 1 and this becomes 0. And the answer is 1. What do we say? We say 0. Shit. Which is true. Shit, this initial 6 had nothing to contribute to anything. Except this initial 6 had nothing to contribute except from the fact that we got this remainder. Except from the fact that we got this remainder. Yes, we are only considering the last m minus 1 things, okay? Which means this is like very good. Okay, this is like very subtle. Here, if can we increase the answer by 1? This 6 had nothing to contribute in the initial in the final answer, except the fact that if there was no 6, if there was just one number, which was 1, which we had to distribute between two boxes where initially both of them had a 0, and we had this one to distribute in between those, we would put it in one box, and the other player would make the value of this box equal to 0, and finally we would have assigning two eggs to 0. But because we had a 6 before and we had a 3 because of that here and a 1 here, instead of making this one 0, the player made this thing 0 and we ended up with a 0 and a 1. That was a contribution made by this. So which means I think we can do res equals 1. This might, we will see, we'll see how it goes. And wrong answer, cool shit. But are we getting the right answer for? Yep, we are getting the right answer for this, but not for others. We are messing up. Shit. We are messing up with this one. Okay. If m greater than 1, this is like too much tinkering to fit the right answer. 19 and 17. This one we are messing up in this one. We are saying the answer is 19, but they are saying that the answer is 17. Okay, let's see. Yes, let's see. Shit. I guess I am not using the right. Yes, I am not using the right compiler for here for the remap. Yeah. 17. We would like to say std. That is how we say s. C++ 20. Let's go. Let's say 23. Not even 20. Turn off codium. Toggle. Google. I lost the problem. CVP, and if we were to compile, it does compile. Cool. We have this one test case, which is this one. Yep, cool. 17. Why 17? See out I. And res. One test case is not this. One test case is this. We had 4. 4 was the initial value of I here. 4, not that our response decreased from 4 to 3. 4 is the initial value of I. Our answer is 2. Lower. 4. 4 means 5. 4. Shit. Shit. I think we don't even have to do this. I think we can just do int I equals 0, and if n is smaller than m. then do this, otherwise do this. Okay, okay. Shit, I thought, okay, I thought we struck gold, but wait, not n. Yeah, that was stupid. N minus I. The remaining number of elements. If I remainder with n plus r. Oh shit, we don't have to do else. Minimum of this. Yeah, this. Okay, I was like actually expecting it to work this time. Okay, why is this 0 here? By one test case, which is this one, the one which gives 1, which is 22767. 22767. 000. That is messed up. We should have increased res here. This is very hackish and probably wrong. You are under arrest. Shit. Something happened. He said something. Cops. Shit. Okay, shit. It is like your Rahul Sharma. You are here with a new account. Hmm. By this point, 2000 people have been able to solve this. Let's look at C. Maybe, just maybe, we might be able to solve this. Okay, let's see. Let n h Be positive integers. Swampy. The alligator needs water for his bathtub, and you are tasked with getting it to him. Above his house, there is an N by H grid of dirt and water tiles with N columns numbered 1 to N in column I. Yep. In column I, the bottom AI tiles are dirt and the rest on the top are water tiles. You to get swamp water to swampy, you can place a drain in any tile that isn't a dirt tile. Okay, placing a drain takes away tiles, all the water tiles that can access the drain by moving only down, left, right on the grid without crossing any dirt tiles. Down, left or right. Okay, left, right, down. Cool. Okay. For example, placing the drain on the X in the grid below will drain both the top, left and right way and result in 10 tiles being drained. I guess we have to like switch this thing upside down because here they said down, only moving down, left or right. Okay, water can move down, left or right. Makes sense. What is the maximum amount of water you can get to Swampy after placing at most 2 drains? Note that water tiles that could have been taken by either drain are only counted once. Okay, so it is like always good to keep this thing at the lowermost place possible. One and two. Cool. 2 trains. N 2000. We can go n square, it seems. So we can go n square. The first line contains 2 integers n and h. N is the like number of columns and height of the grid. H can be very big. H can be very big. Okay, this takes stack. I think we can use a stack method here and we can do one pass and calculate like if we were to have a drain here, what would be the maximum water shade, but also we are not counting the same thing twice, which is messed up, which is a bit messed up. N square log n. Instead of counting what are the cells that will be reachable by this, it is, I think, easier to count what are the cells that are not reachable. But the problem is, the more difficult problem here is we have to put 2 drains down. Hello. Yep, 8 more problems to go. You are under timeout. Ah, this is way too hard. I think the main problem is exhaustion, maybe, rather than logical thinking. So take a long break after each problem. I have like the whole day remaining anyway. Wait, shit. Your ID? Shit. Okay. Uh, that is a very intimate question to ask someone, but okay. Don't mind. Walrus. How do you? 137. Cool. This thing. Wait, shit. Is this your another? I am just supposing Dom DMK is Rahul with another account. Shit, it might be that all the people here are just Rahul coming from another account. Shit, and you are watching this stream from your seven different accounts at the same time. That is crazy. How to think? How to think? Yes, there is a thing. How to think? Here, go to catalogs. Here, there is how to read a problem, and then how to come up with solutions. 10 years ago, 7 years ago. These are cool articles. Basic rules are cool. Shorter means better, simpler means better. So size does not matter. And the result of reading the statement is usually pure math model. You have to get a math model. Just like remove the story and get a math model and solve the math problem. 1 MSTU. I don't guess. Vikas, your name is Vikas. I don't get the reference. I'm stuck in 1100 and 1200. It isn't there a phrase? Shit, I forgot what the phrase is. Can't work. Then, if you can't study, if you cannot study, then work. If you cannot work, something like this. If you cannot work, then study. If not study, then sleep. Something on the lines of this thing. Quote, not specifically related to study, but the essence of the quote was that if you are facing problems and doing something, like actionably doing something, solving problems or like something like that. Stuck on 300. Shit, Rahul, if you are facing problem in doing a problem, then you should go and study and like improve your theory part. And if you are not facing problem with theory, then sleep. And like keep switching between problems and reading about theory. And for theory, this book is pretty cool. Competitive Programmer's Handbook. This CP handbook. This has topics, and I guess these topics are enough to get you to 2000. But I'm like, I cannot say how to get to 2000. I am not at 2000. But this is what I think. Shit, I cannot change the color. Yep, this thing has quite a lot of cool things. And if the explanation of topics in this book is not sufficient for you to understand them, then you can look at other resources. But the main selling point of this book is that at least you would know that there are these topics which you can learn about. Like here, the explanation given here or the context given here for pruning the search might not be enough. Like you might need more to understand the concept of pruning, but at least you do know that there is a thing called pruning. And now you can go and look up on YouTube and other things to look up more on pruning. That is cool. Thanks. Are you Indian student? Yes, I am Indian student. Me from Meerut. Because okay, shit, you are giving points. And you are not responding to my allegations of you being Rahul Sharma. So I suppose my allegations are correct. The methods of thinking are very abstract. Most people advise. Okay, if it was possible, we could just have one article on how to think. Everyone would read that and become genius. There is because like language is not sufficient for communication. Words are not sufficient for communication. There is no other way to learn how to think other than applying your thinking constantly and helping it change. Yes, like instinct. uh, there is something which Jordan Peterson said, that internally you have the things that you know, right? And then that you know, and then you have the things that you like kind of know, and then outside you don't know shit. Outside this circle you don't know shit. So it is easier to use language to explain these things to other people, but it is quite difficult to explain these things, the things that you kind of know. So I kind of know about my intuition in CP, but I cannot tell you that intuition, like, yeah, I like kind of know. And this is mostly related to subconscious SC, shit, that SCST, subconscious. And outside this thing you don't know shit, and you cannot use language. Language is a good tool to express these things to other people, but not this, the things that you kind of know. And these things, the things that you kind of know, these are well expressed through stories or through movies or through art, like like black paintings, Goya, Saturn. This thing, that is crazy. You cannot use words to explain this thing. You just kind of know this. This is Saturn. He is eating his seventh or eighth son, I think, because it was prophesized that his son will kill him when he grows up, so he is eating his son. Like, yo, I don't know why. Wait, wait. I have solved 500 plus problems, but I still struggling. Shit, that is crazy. 500 problems. I guess in that case, you are not taking out as much as you can from a single problem. After you solve a problem, if you want some advice, like, I might be just yapping and no one might be listening. After solving a problem, figure out what was the essential thing which you must have known to solve this problem. Like, if you didn't know this thing, you would not have been able to solve this problem. And if you were not able to solve this problem and you looked at the solution, then what was the thing that you saw from the solution, that specific thing which you got from the solution by which you are able to solve it now? Yep. And having a good memory helps. And this thing just is in the category of things you don't kind of know. So yeah, it is hard to express. Back to this shit. Level 3, Davis Lewis Ortega. Where is my water? Ortega. Shit. Wait, like, I guess this is the theme of this whole thing. Okay, in the next stream, whenever I will do a CP stream, I will read the solution for this one and this one. Shit. Let's now try to solve this. One night at Freddy's. We want to distribute numbers. We want to distribute numbers. We are not able to do so. That is messed up. One, two, cool. One. The remainder is the only thing that I'm not able to get right. The person making the values 0 will only go after the wait. Does volume matter the most? Okay, share. I thought you were saying my volume is low. Yo. Well, it depends on your training method. Bro, what was the level of those 500 questions you solved? Yep. Where are you solving these from? The thing is that some concepts are way too precise to explain them in abstract or general way. Yep. Some are. Nope, not yet. No, you were right. This is difficult. Does volume matter? The most under 600. I think not the most. Like you are saying, you have solved 500 and you are not able to go up above 1100 and 1200. So volume like does not matter too much. Your quality matters. Remainder. When we do have a remainder, when are we able to preserve that remainder? That is the problem. When are we able to preserve that remainder? Okay, I think shit. This goes here and this one goes here. Okay. Mm, nope, nope. What if I'm stuck at 1100 pro after solving 500 problems? I can just ask ChatGPT for the help it gets. No, no, shit. No, like look at other people's solutions after that and why such a range of emotions. Shit, you're getting too emotional. Here, the answer is one. We want the remainder from this. 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 And only in this. Right, okay. Greater than shit, okay. Guess we solve. Ah, shit, I was expecting that we would get the right answer for this, but mm, plus one, plus one, plus one, plus one. Okay, okay, we are getting the right answer for this. We are messing up 19s. This 19 and the other 19. This one is 19. No, this one. We are getting 20 for them. Well, what if you try to maximize understanding plus volume? Both by not spending more than 30 minutes on a problem, but also making sure you understand it deeply. Okay, that is the best of both worlds. After seeing the solution, or should you try to sit with a problem for a whole day and force yourself to solve it? Nope, the second advice does not always work well. Like in this problem, I have spent more than 1 hour, I guess like 2 hours on this one, but I'm still spending time on this because I think I have some idea. I have not exhausted all the possibilities, all the ideas I have in my head, which I can apply here. But yeah, you can generally tell if you can solve a problem after spending more time, or if you need to look at a solution. If I had no idea about what to do here, I would have looked at the solution, but I do have some idea. I do not know exactly what, but some idea. So I'm spending more time here. As ChatGPT, because the language is way better on CF. On CF, of the language is way more condensed. CF language is condensed, but I look at it in the sense that this is making my understanding, my ability to understand something that is not explained well. Yeah, my ability to understand something which is not explained well. So yeah, that is why it is like cool, because when you talk to people, they will not give you the best possible explanation of their thoughts. So uh, going through CF problems which are a bit more difficult to digest is pretty cool. Helps you. It helps you. Yep. 1, 2, 3, 4. Shit. Copy with Y. No, don't know. Share. Copy this. Cool. Paste. Cool. We have 5 boxes. And this one doesn't matter. This matters. This matters. This matters. They do increase the value. No, shit. Why do we have one here? That does not. Because remainder. Shit, yes. not about this 19. If this is not even the right problem, this is one. Why are we getting 20 here? 20, 20, 5, 17 plus 3, 20 plus 3 from the end, yep, and that will be there. And 5, okay, 5, 5, no shit, it should have been 1, 4. If there is a remainder, okay, cool. If there is a remainder, cool. Now if there is a remainder, if we are in the category of n minus 1 is smaller than m, n minus 1 is smaller than m, and I is not equal to 0, then do res plus plus else if this thing is greater than 1, then res plus plus, or we could just say the same thing here. With or shit. Okay. Remained, remained, remained. Or maybe it might turn out at the end that the solution has nothing to do with the remainder. Shit, this is very mathematically heavy. The context and this contest have how many problems? This one has a lot of problems. Like look at this. This one has like problems till H. Like Bowser's Castle hard, medium easy, shit, toothless, Anabi. Constructive version, counting version. Yep, still shared. Only 2000 people have been able to solve this one, and more people have solved C than have solved B, which is crazy. And only like one dude has solved H1 and only one H3. Crazy problems. I asked ChatGPT because, well, that would get me the deepest understanding, the fastest. I mean, yes, it is. I mean, this is more of a personal preference. Like you color, like which color do you like? Red or blue or something else, maybe black. And speed. Yeah, speed is a personal preference, I guess. Yeah. If you want to do things fast, then yeah, that is one choice you can do. And this is, and one more argument I think we can relate this to is the difference between artificial diamonds and real diamonds. I would compare using ChatGPT as artificial diamond, not spending more time and getting to the result in the fastest way possible. And real diamonds would be compared to like manually going through the whole process, reading a 1000 page book of algorithms, and then making some conclusion which might turn out to be wrong because you misunderstood something at the start. Yeah, so it is more about personal preference, however you are getting things done. Yep, they can be difficult, but if you spend more time, they become more readable. Shit, there was some celebration. Toothless. Yep, and it just tells me I have to spend more time on theory. And also, there are some problems here which I have not solved. So, yep, I should give them their due time. That would be cool. 1987. Shit, does not make sense yet. I guess there is no point in spending more time at this thing. Okay, but I'm going to go meditate then solve. Okay, shit. That meditation, you are going to do meditation that just confirms that you are uh, Rahul Sharma. Then solve one more problem after 30 minutes, then seven remaining problems. Let's go. All the best. Okay, but at that point, what's worth more? Speed. Yes, if you want to speed versus exploration, exploring possibilities. Okay, the thing is, there are benefits in both. When you are looking for some solution and you ask ChatGPT for that exact thing, ChatGPT will tell you that exact thing. But us humans, for us humans, it is better at times, not always, but at times, better to have a thing in context. If you are not using ChatGPT but going through editorials and things for understanding some topic or some problem, then you will not be able to get to the exact point that you want to get to without exploring some other random off the branch things. And when you go through this whole thing and then get to the main juice of the thing, you have all this context which can help you remember this thing when you need it the next time. But when you are getting to the exact thing at that, the exact thing, however, by whatever means, then you might not be able to remember this. But here we also have to make a distinction between a beginner and a pro. I guess a pro person, if you tell a pro person one very specific exact thing without the context, a pro person will be able to extract more from that compared to a beginner person, because the pro person already has the context in his brain or her brain, whatever. But a beginner person doesn't know shit. She needs the context to remember the thing. Like that is why stories are very effective. They give like context and stuff. Imagine if you have given this. Yep. Frustration of yep. It was cool. Yeah, shit. The frustration would have been crazy. Self doubt and stuff. Also, in yesterday's context, people took more time in B and solved in 15 minutes. It's crazy. I think it is better to solve C now. First now. Yep, I guess that is becoming a norm now. Norm. It also, just on the note of norm, I would like to say Norm McDonald's. He's like dead, but he was one of the best comedians ever. Just shout out. Shit, okay, that is like too long. Uh, I guess search question mark and search question mark Q equal to this. Yep, question mark. Yes, let's play a game. Question mark Q equals or plus McDonald. I think that would work if I were to click on this. Yep, that does work. We have given a query parameter. Let's play a game. Like contest can go away for now. Let's play a game. Shit, and Dom DMK was just here. He's also good at chess. Look at this notification. Remember my decision? Yep. Play with a friend. Let's play a game. You are online. Okay, I'll do my best to beat you. Okay. Give your worst or whatever. Cool. That is why I removed that pawn, because I remember the last time you like messed me up. You trapped my queen the last time. Shit, makes sense. Makes sense. Yeah. Yep. GG. Mm, okay. Share. GG. Yeah. Cool. What is the score now? I don't know. What is the score now? I guess you have defeated me twice, and I have defeated you once. Yep. So yep, I'm on the losing side. Cool. This was cool and did mess up quite a bit. 3-1. Shit. Okay. Shit. I have to work hard. Work hard to get better at chess. And also for today, that would be it. For this stream, we did this contest thing, and it was cool. We did. Shit. Okay. I'm like losing even more. Hit profile. Opponent. Okay. Shit. Yes. Ah. Shit. Okay. It is 4-1. It is 4-1. You have defeated me four times. Shit. And it was never a draw. He even said, ah. It just shit. Just shows how much IQ you have. Okay. React documentation is here. Cool. And now I will go. This would be it for today. And before going, I would like to say this thing, point out this psychological significance of biblical narrative by Jordan Peterson. And yeah, this is not less about religion and more about psychology. You can learn quite a bit about psychology from this. And yeah, I'm just like giving out this, even though no one asked. Cool. And that would be it for today. We did a contest and only solved one problem. Crazy shit. And that would be it for today's stream. And thank you for being here. Bye.